All right, here we go with another video lesson from your favorite teacher. I think yesterday's went well. When I get back on Monday, we'll go over some of these lessons together, see how you're doing. So we'll start this first page. From prior lessons, you have learned that a linear equation can be represented by a straight line on a coordinate plane. In this lesson, you will learn how to look at two sets of points or two equations to determine whether their lines are parallel or perpendicular. Two lines are parallel if they have the same slope but different y-intercepts. So these first examples will be looking to see if lines are parallel. We need to check the slope first, see if they're the same, and then if they are, we'll check and see if the y-intercepts are different. Our first example, we have two lines in this picture, line A and line B here. And to check their slopes, we got basically three different ways. The first way is using the slope formula. They took the points from line A here, which are, one of them is -1, -2. That's this point down here. And then the other point they plotted right here was where x is 1 and y is 2. So remember, if you're using the slope formula, you can label those points x and y. These are the ones, x and y. These are the twos. And so they put that in the formula in this first one for line A. We got, of course, y2, which is 2, minus y1, which is a -2. And 2 minus -2 is 4 on top. Then on the bottom, you have x2, which is 1, minus x1, which is -1, and 1 minus -1 is 2. And then 4 divided by 2 is 2. So that's using the slope formula. We can see that the slope of line A is 2. They also did it with rise and run. Remember, slope can be considered the rise over the run, the y direction over the x direction. And we can see from this point to the other point, we're going to rise 4 and run 2. So rise 4 on top, run 2 on the bottom, and 4 divided by 2 again is 2. The slope of, I'm sorry, the y-intercept of this line right here, we can see it in the picture, is 0, 0. Now my favorite way, and we're going to do this a lot today, is of course using the calculator. Let's see, let me quit here. Stat edit, stat calc. What will give us the slope and intercept? Well, basically the whole equation. So turn your calculators on now. Let's practice that one time with this same one. We've seen two ways where we got the slope of 2. Let's check stat edit, stat calc. So stat right there. And then edit is number 1, or just hit enter, either way. And remember, when you're clearing out old data, just go to the top. I'm going to go to the top of L1 and hit clear, not delete, and then come back down and that stuff will be gone. So we're going to put in those x's in the L1 column. We've got -1, enter, and the other x is 1. And we'll go over here to the y L2 column, put in the y's. So the first y1 was -2 there. Y2 is 2. We've got our information in there. Now we'll go stat calc, stat, and then over to the right to calculate, calc. And of course, it's number 4, linear regression, linreg. So I'll hit 4. And you get this screen or that other big one, the other big one with all the different things in. You just keep hitting enter until it calculates this one time. All right, so we can see y equals ax plus b. They use a instead of the mx plus b. So a is our slope, and you can see it's 2 right there. And you can also see the y-intercept b is 0, just like in the picture. Now we'll go ahead and look at line B. And look at its slope and intercept. Of course, here's the calculations. They've done it already. Y2, 3 minus y1, which is negative 3, comes out to 6 on top. X2 here, the negative 4, minus x1, which is the negative 7, comes out to a positive 3, and 6 divided by 3 is 2. We can also see it with the rise and run method. The rise 6 over the run 3, 6 over 3, again is 2. And the y-intercept of this one, well, it's way up here. Looks like at positive 11. They're definitely different, huh? 0 and 11. So now again, both the lines had a slope of 2. I won't take the time to use StatEdit and StatCalc since this is already done for you. We'll use it again a little later, but that is the easiest way. Line A and B are parallel since they have what? The same slope, but different y-intercepts. Okay, and they look parallel. Parallel lines do not intersect. They're just going to run alongside each other for a while. So do this, try it together. It says to graph the pair of lines to identify the slope and y-intercept and determine if the given lines are parallel or not. So they want to know if they're parallel. And instead of graphing, I'm going to do it the easy way. And I consider the easy way StatEdit, StatCalc, using my calculator. You can graph it if you would like. You know, maybe after we're done, graph those 2 points for line A and draw a line. Graph those 2 points for line B and draw a line. See if they look parallel. But I'm going to go ahead and do it this easy way. So I'm going to get my calculator out, go back to Stat, and Edit. Go clear out this old stuff, go to the top, hit clear, come back down. Do it for the L1 column 2. And now I'll put in the points for line A. We got X is 5, and the other X is negative 4. Go over and put in the Y's. First Y is negative 3. And the second point we have Y is 6. We'll go ahead and stat calc now. Stat, go over to the right to calculate, and it's number 4, linear regression. Hit enter. And now I can see my A, the slope is negative 1 for this line. And the y-intercept B is 2. That's simple. Now let's do the same thing for the second one. Line B has these 2 points, 1, 5 and negative 2, 7. StatEdit. Let's clear out. The L1 column, clear it. All right, the X is 1 and negative 2. So 1, negative 2, boom. That easy. The Y's, we got 5 and 7. And then stat calc, number 4. And we can see the slope of this line is negative 0.666666, or negative 2/3. So I can see right now their slopes are not the same. They're not equal. The y-intercept was 5.6666. But since the slopes are not equal, these lines are not going to be parallel. Again, you can graph them again and look and see they're not the same slope. They will eventually intersect each other. All right, I'm going to go ahead and do this B example right here with line A and line B. If you don't need this, you can pause it and do it yourself here. Again, I like the StatEdit, StatCalc way. I'll go ahead and edit. I got my cleared out. L1 clear. All right, well, let's put in the x's, negative 2 and 3 for the x's. And we have the same thing for the y's, -2 and 3. Ready to stat calc, stat button, over to calc. Linear regression is number 4. So we can see now we got A is 1 and B is 0 for this first line. So the slope is 1 and the y-intercept is 0. Let's check our second line now, line B. Clear it all out. The x's are -1 and 6. And the y is -5 and 2. So as I'm putting in this, I'm looking at exactly why I put in the right numbers. Now that's about the only way you can miss this problem, by typing in the wrong numbers. So stat calc, number 4. And again, A, the slope with the calculator, is 1 and B is -4. The y-intercept is -4. So now we check the slopes. They are equal. That's good. And the y-intercepts are not. So these are our parallel lines. The slopes are equal and the y-intercepts are different, so the lines are parallel. It's that easy. The next one I'm going to let you go ahead and do, and I will check it later. Use your stat edit. Stat calc is the easiest way. Good luck. You can pause this video at any time. Remember that to catch up with any notes if it's going too fast. Me, I'm tired and want to get to bed, so I'm running through this a little quick. Our next example is with equations. We said we'd give it, check to see if lines are parallel with a set of points or with two equations. See if two equations represent parallel lines. To determine if two lines are parallel by looking at the equations, first make sure they're written in slope-intercept form. That way we can see the slopes, see if they're the same, and then see the y-intercept, see if they are different. Then just look at the slope to see if they're the same, right? All right, so the first equation is in slope-intercept form. Y equals 1/2 x plus 4. So I can see the slope of this line is 1/2 and the y-intercept is 4. The second equation is in standard form, so we're going to go ahead and solve it for y like we did the other day when we were looking at standard form. All right, so the second equation, what do we want to get y by itself? So we'll get rid of this -2x first with +2x. So the x's go away. We're left with just the 4y on the side, and it is positive. Make sure you look at that sign in front of the y. Equals, and I like my x first, 2x, and then the +8. Then, of course, we're going to divide by 4 everything to get y by itself. And then the 2/4 reduces to 1/2, and the 8 divided by 4 is 2. So now we got that in slope-intercept form. Again, the first equation, we had a slope of 1/2 and a y-intercept of 4. In this second equation, we can see the slope is 1/2 and the y-intercept is 2. So these equations are parallel since the slopes are the same and the y-intercepts are different. Okay, same slope but different y-intercept means parallel lines. That slope is a slant. That easy. Just get it, the two equations in slope-intercept form and look at the slope and intercept. Let's go ahead and do another one together. Here's our two equations. Again, the first one is already in y equals mx plus b, slope-intercept form. So we can look at it and see that the slope is -6 and the y-intercept is -2. Second equation we will have to put into slope-intercept form. So the first step is to get rid of these x's over here. -12x to both sides. Cancels out over here. We are left with the +2y. And over here, we'll put our x term first, negative 12x, and that's a positive 10 there. Last step to get y by itself is divide by this coefficient, divide by 2. So we divide each thing by 2. Over here, we'll get y. Negative 12 divided by 2 is negative 6x, and then 10 divided by 2 is 5. So we can see the slope of this line now, that is in slope-intercept form, is negative 6. The y-intercept is a positive 5. Compared with the other one, we have the same slopes, negative 6, but different y-intercepts. So these lines are parallel. That easy. One more here. Give it to you also. If you want to pause the video and try it yourself first, that would be a good idea, and then check your answer with the video. Now I'll go ahead and do it again. You can pause it first, get a little practice in there. So neither of these equations are in slope-intercept form, so we're going to have to solve them both for y. Get rid of the x term first with plus 6x. So that goes away. We'll be left with a positive 2y on that side. Equals, on this side we got the 6x and the plus 8. We'll divide by 2 now to get y by itself. And we end up with y equals, here 6x divided by 2 is 3x. 8 divided by 2 is 4. And so we can see the slope and y-intercept now. But the slope is 3 and the y-intercept b is 4. Our second line over here, let's solve it and get rid of those two x's first with minus 2x. That leaves us with 4y on this left side. Over here we'll have minus 2x and a minus 12. Now we need to divide by 4. Over here we got y. Negative 2x divided by 4, negative 1/2 x. Negative 12 divided by 4 is negative 3. So now we can see the slope of this line is negative 1/2 and the y-intercept is negative 3. Comparing the two lines, the slopes are not the same, so we can stop there and say these lines are not parallel. Slopes are not equal, so the lines are not parallel. Doesn't matter what the y-intercepts, that they're different. First, check the slopes. All right, I hope that's easy for you. The next part's a little bit tougher, a little bit different, learning what perpendicular lines are. Perpendicular lines do intersect, and they intersect at 90-degree angles. That's what's special about them. Now, what's true about the slopes here? When you're looking at, when you are working with perpendicular lines, you will have to remember two opposites, it says. If you notice on these perpendicular lines, one of them is going up. Here, this one right here is going up, which means it has a positive slope, and the other is going down, which means it has a negative slope. That's what happens with perpendicular lines in the coordinate plane. One has a positive and one has a negative. That's the first opposite. The other thing that needs to be opposite to make a perpendicular line is the slope values. So what you need to do is take the slope of the original line and flip it over so that you have the opposite slope. This is called the reciprocal. Reciprocal means you flip a fraction around and the top becomes the bottom and the bottom becomes the top. We'll see some examples of that. One last note, you can also determine if lines are perpendicular if the product of the two slopes equal -1. In other words, if you take these two slopes and multiply them and they're perpendicular, you will always get the number -1 when you multiply them. So let's look at a few examples on perpendicular slopes. Determine the slope, which is the opposite reciprocal. Again, that's what we're looking for in perpendicular lines is opposite reciprocal. So we're going to just practice finding them. So if we have this equation right here, y equals 2/3 x plus 5, the slope of this line right now is 2/3. So how do we find the opposite reciprocal of 2/3? Well, you start with that 2/3. You find the reciprocal, which means flip it over. So the bottom becomes the top and the top becomes the bottom. So now we have 3/2. Then the second opposite part is write the opposite sign. This was positive, so now stick a negative sign in front of it. So one is positive, one is negative. So we flipped it and then took the opposite sign. And that is now, so negative 3/2 is the opposite reciprocal of what we started with 2/3. And if lines had these kind of slopes, they would be considered perpendicular. It doesn't matter about the y-intercept, it's all about the slope with perpendicular lines. All right, let's do a couple of triads here. Find the opposite reciprocal for these and write the perpendicular. We're not actually going to write the perpendicular equation here. Let me check. I think I got the wrong example here. Let me pause it. Okay, I found my way again here. The only difference on your paper is it does not say write, then write, and write the perpendicular equation. So we're just going to find the opposite reciprocal of these. Get rid of that here on mine. All right, so we start off with y equals 1/4 x plus 3. So we want the opposite reciprocal slope of this one. This one has a slope of 1/4. So we'll start with the 1/4. The first step, got a two-step problem here, is to flip it. So it becomes 4/1. Now 4/1 really just equals the number 4. So we can write that now. And the second opposite is to what? Take the opposite sign. This is positive, so our opposite reciprocal will be negative. Okay, give it the opposite sign. So we started off with 1/4, we flipped it, we simplified that, and 4/1 is just 4. And then we took the opposite sign, -4. So 1/4 and -4 are opposite reciprocals. If you look at the second one, we have a slope of -2/5. So start with -2/5. Then we flip it. Will be -5/2. And then we give it the opposite sign. The opposite of a negative is a positive. So we end up with +5/2. So -2/5 and +5/2 are opposite reciprocals. That's what we're looking for in slopes with that are perpendicular. So these, let's take a look at some problems like that. Yeah, one more opposite reciprocal problem. Here, this line has a slope of 5, so we start with 5. We'll go ahead and write it as a fraction. So you can always take a whole number and put it over 1. That way we'll be able to flip it in this first one. So that's the only thing new in this one. You got a whole number or an integer, put it over 1, and then you can flip it. So now the first opposite is flipping it, 1/5. Then we have to change the sign. This was positive, so the new one will be negative. So the opposite reciprocal slope of 5 is -1/5. Okay. Here's this, try it. Find the slope, which is the opposite reciprocal to each equation. Let's see. So the first one, y equals -3x plus 4. So the slope of this line is -3. We start with -3. Now that's not a fraction, so we'll write it as a fraction. Negative 3 over 1. Now we'll flip it. We got negative 1 over 3. Now we'll change the sign. This was negative, so the new one will be positive. So the opposite reciprocal of negative 3 is positive 1/3. Our next example 5. Identify perpendicular lines by using 2 points. All right, so we're given 2 points. One line that passes through these 2 points, the second line that passes through these 2 points. Are they perpendicular? Well, if they're perpendicular, we look at the slopes. If they're opposite reciprocals, then we have perpendicular lines. So they use the slope formula. So we'll just look at their work. I, again, would use StatEdit and StatCalc and just look at the slopes that the calculator gives me, putting in the 2 points. And you may verify that if you would like. Just look at their work with the slope formula. Looks good. They took y2, which is 3, minus y1, which is negative 27. And that does come out to a positive 30. Then the x is x2, which is 1 minus x, the first x1, which is negative 5, and that comes out to 6. And 30 divided by 6 is 5. A lot of times what I'll do is go ahead and take the opposite reciprocal of that, figure it out myself before I do the second line. The second line does come out to negative 1/5. And yes, I believe that is the opposite reciprocal. One's positive, one's negative. If you put this over 1 and flipped it, you would get 1 over 5. One last check we mentioned earlier is that if they really are opposite reciprocals and you multiply them right here, you should get negative 1 every time. And we do. You can try that with your calculator. So since these are opposite reciprocals, these lines are perpendicular. Okay. Take a look at another one. Here you go, determine if the following pair are perpendicular or not. So yeah, I'm going to do it the easy way, StatEdit, StatCalc, linear regression. Let's take a look at this first one. Put my calculator on. StatEdit. Let's go clear this stuff out. Easy as pie with this thing. Use that powerful calculator. So line 1, I can see the x's are 1 and negative 2. And the y's are negative 3 and 4. All right, looks good. StatCalc. Number 4 for linear regression. And we get the slope negative 2.33333. Ooh, this is where it gets a little rough, huh? I think I'm gonna pause right here for a second. Now here's an example where it might be, a little easier to do it with the slope formula. Instead of getting this ugly decimal here, we have to turn into a fraction. Let's see, what can I do? Well, I think it would be best to go ahead and use the slope formula for this. So if you'll go ahead and do that, I will too. Hang on. Because I don't like the idea of, trying to teach you how to turn this back into it. Ay, 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 ay. Didn't think of that. So I'm going to go ahead and use the slope formula for this first one. I'll check the other one with the calculator. Maybe we'll get away with it. But So I'll label them like we're supposed to. So x1, y1, x2, y2, and you've got that formula chart. It says take y2, which is 4, minus y1, -3. On the bottom, x2, -2, minus x1, which is 1. So you can use your calculator to do the subtraction. We'll get 7 on top and -3 on the bottom. All right, or -7/3. Now me, I like to, let's see what happens if I flip this. I'll have 3/7, right? This thing was negative. This one's going to be positive. So if this is the opposite reciprocal, we should get 3/7 to see if they're perpendicular. So we'll go ahead and use the slope formula on this one also. Let's take a look. Let's see. We'll have this as our y2, 7. Over here will be our y1 minus y1, 5. On the bottom, what do we have? X2 is -4. Minus x1, which is 2. And right here, 7 minus 5 is 2. And on the bottom, -4 minus 2 is -6. And if you go ahead and divide this out, you will get will reduce to -1/3, which again is not the opposite reciprocal of this, -7/3. It should have come out to this, 3/7, we figured out. So these are not perpendicular. So you can write that for your final answer. I'm running out of room here. No, not perpendicular. Take a look at the other one. I'll try with the calculator again, see if we get some nasty little fraction or not. So again, it's not always the best to use this StatAdd and StatCalc, but we'll give it another shot here. Stat, edit, clear it out. All right, so my x's are -3 and 1 in that first line. And the y's are 9 and 1. All right, StatCalc. All right, so this one we got here's our slope, the a number, right, ax. So the slope of this one is -2. And we'll put it down here, -2. So let's see what would be the negative reciprocal of that. So we start by making it into a fraction, -2/1. We flip it, we'll have 1/2. This one was negative, this one's positive. So we're looking for the negative reciprocal to be perpendicular to be 1/2. So I can do that with the calculator. It'll probably just tell me it's 0.5 if it's right. So let's do StatAdd and StatCalc again. So our x's are -2 and 2. And our y's are -3 and -1. All right, StatCalc time. Number 4. And we did get a positive 0.5. Again, you can put 0.5 in math fraction, and you'll see it's 1/2. So we got -2 and 1/2. And these are, you want to double check, multiply them, you'll get -1. So these lines are perpendicular. So you can put yes or perpendicular, be fine for an answer for that. Our last type of one is still with perpendicular, but using equations now and looking to see if they're perpendicular. To determine if the two lines are perpendicular by looking at their equations, first make sure they are written in slope-intercept form, and then look at the slope to see if it is opposite reciprocals. Remember, you can always take those two numbers and multiply them and see if you get -1. Let's see here. So here's our line. Our first line A is already in slope-intercept form. We can see the slope is 3. Okay. So let's see, what's the opposite reciprocal of 3? Well, we put the 3 over 1. We flip it. The first one was positive, so this one would have to be negative. So we're looking for -1/3 in the second line. So in the second line is not in slope-intercept form, so you can see their steps for solving it. We're going to get rid of the x's first, -2x to both sides. That leaves us 6y equals -2x plus 12. Then we're going to divide everything by 6. 6y divided by 6 is y. Here's the -26x. 12 divided by 6 is 2. And then this reduces to -1/3 x. And our slope right here, -1/3, was what we were looking for. 3 and -1/3 are opposite reciprocals. If you want to double check, take and multiply 3 times -1/3 and you should get -1. So yes, these lines are perpendicular. They intersect at a 90-degree angle here. Let's see, I think I got one last try it. And a couple actually. Let's see. Let me make sure these are on yours. All right, finish up this last example here. It's been a long one. You guys go on and see how much work you can get done after this. I know it's been a long lesson here, almost 40 minutes right now. So we got our two equations. Neither one is in slope-intercept form, so let's solve them. Let's get rid of these x's here. We got -2x, so let's cancel that out with +2x and get this 3y by itself. So we got a 3y equals on this side, we got the 2x and then a +9 plus 9. Now let's get rid of that 3 to get y by itself by dividing everything by 3. Divide by 3, divide by 3, divide by 3. Over here we get y equals 2 divided by 3, and then math fraction, we'll still get that same fraction, 2/3 x, and then 9 divided by 3 is 3. So now we have it in slope-intercept form. We can see our slope here in front of x, the coefficient of x, 2/3. So the slope of the first line is 2/3. Let's see. What are we looking for for perpendicular? Let's see, the negative reciprocal. So if we flipped it over, we'd have 3 over 2, right? And since this one's positive, this one would have to be negative. So we're looking in the second one, if it comes out to -3 over 2, these lines will be perpendicular. So let's solve it. We'll get rid of this 3x with -3x. So remember, watch out for this sign. What's left over here is not 2y, but -2y. So we have -2y equals on this side the -3x and the +8 plus 8. So now we need to divide by -2. And over here we'll get y. If we take -3 divided by -2 and then math fraction, you see the negatives cancel out and we get +3/2 x. over 8 minus 2 is negative 4. 8 divided by negative 2 is negative 4. So now we can see the slope of this line is 3 over 2, but it's positive. We needed it to come out to negative because one's going to be positive and one's going to be negative. So these lines are not perpendicular. Okay? So write that, not perpendicular, on your paper. That is the end of it here. I do have a little summary I want to go over with you though. We studied two things here, parallel lines and perpendicular lines. How do we check and see if the lines are parallel? Well, they have to have the same slope first, and then if they do have the same slope, check and see if they have different y-intercepts. So two things to be parallel lines, same slopes but different y-intercepts. Perpendicular lines, on the other hand, we just have to look at the slopes. The slopes that are opposite reciprocals, like 5 and negative 1/5. Remember, a good check is to multiply these numbers. Matter of fact, I haven't done that yet, so I'll show it to you with the calculator. Those are negative reciprocals. When I multiply them, if I take 5 times, I'm going to put that fraction in parentheses, negative 1 divided by 5, I get what I'm supposed to, negative 1. Yes, those are negative reciprocals of each other. So again, remember those. You might even write that down again. Parallel lines, same slopes, different y-intercepts. Perpendicular lines have slopes that are opposite reciprocals. And last, ways you look at these. If you are given two ordered pairs, most of the time we can use stat edit, stat calc to find the slope and the y-intercept. We can definitely do that with parallel lines. Perpendicular, sometimes we get those weird ones that are tough to translate, so we might just have to use a slope formula to look at the slopes. If you're given two equations, what do you want to see the slope and the y-intercepts? Well, slope-intercept form. So any equations you get, put them in slope-intercept form if they're not already, and then it's real easy to see the slope and the y-intercept numbers. Alrighty, I'll see you Monday. You finish up what you can today. Have a great weekend.